Now let us try to look at some of the properties of the square numbers. Now what I have done over here is I have written down the numbers from starting from 1 and its square number. So this we have column 1, column 2. So this covers the numbers from 1 to 10 and their squares. Similarly, in the third column, we have numbers starting from 11 going all the way down to 20 and their squares are given in column number 4. Now what we are going to do to begin with is to start observing these numbers, the square numbers, and see if we could derive relations or some properties of these numbers. We'll just look at that. Now first, let's begin to look at the digits in units place. So we are looking at digits in units place for the square numbers. So if we start from 1, so we have 1, 4, 9, 6, 5, 6. So whenever we come across a unique digit, I'll just write it over here. So the first one, let's say for 1, it is 1. Then for 2 square is 4, which means the units digit is 4. For 3 square it is 9, so that is a unique digit, so we put it 9. Then we have 6, so that is for 4 4s are 16, so we have 6 over here. Okay, you come to 5, it is 5 times 5 is 25. Okay, so we will put a 5 over here. Now 6, okay, it's already covered. For the 7 squared is 49, but then we have 9 already covered over here. Then 8 times 8 is 64. The units digit is 4 here, but we have 4 covered over here. Then we have 9 times 9 is 81, but then we already said, we have covered 1 earlier. And then, okay, 10 times 10 is 100, so we get one more digit, which is a 0. Okay, now if you look at the squares of numbers from 11 to 20 and we look at the digits in the units place, so we have 1, 4, 9, 6. You can see 1, 4, 9, 6, and then you have again 5, 6, 9, 4, 1 and 0. So you could actually make this, make a separate table which has squares from square numbers from starting for numbers that start from 20 and so on. And in fact, you can actually do it for as many numbers as you like using a calculator. And what we will find is that the square numbers always have one of these numbers in the units place. So if I were to arrange these numbers in the ascending order, then it would be 0, 1, 4, 5, 6 and 9. Okay, square numbers will always have one of these digits in their unit place. Either it has to be a 0, 1, 4, 5, 6 or 9, which means that the square numbers cannot have, for example, 2, 3, okay, 7, 8. You cannot have these digits in the units place for any square number, and this property is very useful just to look at a number and tell by inspection whether it's a square number or not. So for example, you were given a number 225. Is this a square number? Yes, potentially, because you can say that yes, 5 is one. If a number has 5 in its units place, it is a square number. It could be a square number, and I'll come to that later. But if you were given a number, let us say 222, clearly you can say that this is not, it cannot be a perfect square, primarily because a square cannot have 2 in its units place as it has a 2 in its units place, and so on. You can apply the same criteria for the other numbers that end, which have a unit digit in unit digit as 3, 7 or 8. Okay, now the other point which I wanted to emphasize is that if a number has any of these digits, that is 0, 1, 4, 5, 6 or 9, does not mean that it is a square number. That is one thing that you keep in mind. So For example, in this case, like we took 225 over here, and 225 we know is a square, right? You can represent it as a product of 15 by 15. But what if you were given 115? Okay, you will find out, we have already, I mean, if we look at this table, we have all the perfect square numbers from 1 to 100, 1 to 400. That's what we have found out, right? And you would find that 115 is not there in any of the square tables. So if you look at it in column number 2 over here, column 2 and column 4, then you will 115 is not there. So just trying to decide that if you have any of these numbers, that is 0, 1, 4, 5, 6 or 9 in the units place, does not mean that it is a square number. It's not the sufficient condition. You need to do some more checks. But on the other hand, we use this property just to say that if a number does not have any of these digits, that is 0, 1, 4, 5, 6 and 9, it simply is not a square number. So to look at it, if you are given a number n, okay, and then what you would check is, do the digits end in 0, 1, 4, 5, 6 and 9? You would just check that. Do the units digit end in any of these numbers? Then in that case, you might be able to conclude it could be a square number. It could be or could not be, right? It could be or could not be. You cannot say it with with full confidence that it is going to be, it is a square or not, unless and until you find out the, you could represent it as a number of n cross n. Whereas on the other hand, if you have 2, 3, 7 or 8 in the units place, okay, then you can clearly say that it is not a square number. And this is one of the properties that is useful just to look, from an inspection, you could just inspect a number and tell whether a number is square or not. Okay, so we'll see some more properties in the coming videos.